Classification of fluids. We can classify fluids under different categories or on the different basis. So first classification is on the basis of nature. So broadly speaking, we can classify fluids on the basis of nature as ideal fluid or real fluid. An ideal fluid is one which has no viscosity, no surface tension and are incompressible. And a real fluid is one which has viscosity, which has surface tension and are compressible. Now what is viscosity? We are going to learn further. What is surface tension? We are going to learn further. And what is incompressibility? We are going to learn further. Now this ideal fluid is your hypothetical concept. What is ideal fluid? Ideal fluid is a hypothetical concept and real fluid is your practical concept. Ideal fluid does not exist and your real fluid, it's all the fluids in the universe are real fluids. Then one question will come into your mind, then you'll be asking, sir, why then, if ideal fluid doesn't exist, then why this concept called ideal fluid? It is done just for analysis purpose or for engineering analysis and calculations. Okay. Classification on the basis of compressibility. Second classification is on the basis of compressibility. Compressibility means the amount or the act or the nature by which you can compress anything, the magnitude or the virtue by which you can compress any fluid. So that is called compressibility. Fluid can be classified into incompressible fluids and compressible fluids. Your incompressible fluids, we consider the liquids as our incompressible fluids, and gases or vapors are considered as to be compressible fluids. The fluids which cannot be compressed are called incompressible and the fluids which can be compressed are called compressible. But you should remember that liquids are theoretically incompressible but practically compressible. But it requires a tremendous amount of pressure and magnitude of compression is negligibly small and hence categorized as incompressible fluids. What I'm saying is, practically you can compress any liquid present in this universe, but the amount of the force or the pressure that you will need will be tremendously, humongously high. Okay, and the amount of compression that you will get will be quite negligible. So theoretically we assume this liquids to be incompressible, but practically it is compressible. So all fluids in this universe are practically compressible. Here I have underlined the word called practically. Practically means yes, practically you can compress any fluids. There is no fluid in this universe which you cannot compress. But for theoretically, we are assuming this liquids as to be incompressible. Why? Because the amount of compression that we get is quite very small and negligible. So better to assume it to be incompressible. Okay. Now here let's see a mild difference between this gas and vapor. What is gas? You can define gas as a gas refers to a substance that has a single defined thermodynamic state at room temperature. So your gas is a thermodynamic state at room temperature. That is why you might have heard that hydrogen gas, oxygen gas, nitrogen gas, because they have their separate thermodynamic states even at room temperatures. But vapor is a conditional thing. It does not have any thermodynamic state at a room temperature. What is it then? A vapor refers to a substance that is a mixture of two phases at room temperature, namely gaseous and liquid phase. So we have two different phases, that is gaseous phase, liquid phase. So it is basically a mixture of these two phases. A gas is a substance above its critical temperature. Now the question arises, at what location do the gases exist? So you can blindly say that the gases always exist above their critical temperature. What is critical temperature? We will know once we start getting into thermodynamics and as the subsequent classes goes on. But for the time being, I'm just telling, I will show you one diagram. You will understand what the critical temperature is. Okay. So vapor is a substance below its critical temperature and below its boiling point. So vapor exists, of course, below critical temperature and that too below the boiling point. So you can say that gas is a state of matter, but your vapor is not a state of matter. Rather, it is a state of equilibrium between a gas and a liquid, which can easily be converted to liquid by applying pressure and without changing the temperature. Please remember this statement. Once we introduce the concept called vapor pressure, we will learn this more in detail. But for the time being, please remove the myth that if I want to convert vapor into liquid, I have to simply change the temperature. No. Without changing the temperature also, you can convert a vapor into a liquid. How? By application of pressure. And this concept is hidden inside the concept of vapor pressure. So once we start learning that, this thing will be clear to you. Now there is also a special term called as steam. Okay, so what is a steam is? Steam is nothing but a gaseous state of water which is beyond the boiling point. Beyond the boiling point. Okay, but below the critical temperature. And this vapor is a gaseous state of water which is below the boiling point. Now let's understand this with a TS diagram. So this TS diagram will be very frequent in thermodynamics or in fluid mechanics, related to thermodynamics. So if you have a very good idea of thermodynamics, you might have come across this term called TS diagram. So this TS diagram, so this is the dome that I have made. So this dome is this line from here to here. This is called the saturated liquid line. This line or this curve is called your saturated vapor line. This point is called your critical temperature or critical point. So, and this is your isobar. So this region is your liquid region. This region is your vapor region. This is your mixture, that is liquid plus vapor. So this is your boiling point region. So I have separated this boiling point, that is throughout, and above this boiling point you can see we have got the existence of steam. Below this boiling point we have got the existence of vapor, and beyond this critical point, that is above in this area, we have got gas. Okay, so you got a rough idea of this. Third classification is your classification on the basis of viscosity. So we have not studied yet what a viscosity is, but for the time being you remember what a viscosity term is. So fluids can be classified under Newtonian fluid and non-Newtonian fluid. What is a Newtonian fluid? A fluid which obeys the Newton's law of viscosity. The liquids or the fluids which follows this law, that is Newton's law of viscosity, will call those fluids as Newtonian fluid. And the fluids which do not obey the Newton's law of viscosity will call those fluids as non-Newtonian fluid. We are not going deep into this Newtonian and non-Newtonian for the time being. Why? Because in order to go deep into this, you have to first understand what a viscosity is. Okay, so in the next lecture we will introduce the list of the properties that we have to study, and we will pick up one by one each property and learn all the properties in detail. Once we study the viscosity, then we will come back here and classify the fluids on the basis of viscosity again. So see you in the next lecture. Till then, bye.